Look closely at the physical universe, and you will find it is governed by two hyper-specific numbers. The first is 1836, the scale of physical matter. The second is 137, the strength of light. Richard Feynman kept 137 written on his blackboard. It is a number present in every interaction between light and matter, yet for decades its origin remained unexplained by any known law of physics. These are the exact parameters of reality. 1836 is the proton-to-electron mass ratio, mu. It dictates the physical heft of every building block of matter. 137 is the inverse fine structure constant, alpha, which dictates how electromagnetism binds those blocks together. They act as the master dials of existence. Tweak the value of either one by even a fraction of a percent, and atoms fall apart. The universe as we know it disappears. We have built massive machines like the ALICE particle detector at CERN to test the standard model of physics. And while the standard model uses 1836 and 137 flawlessly in its calculations, it cannot explain why they exist. They are what physicists call free parameters. We measure them in nature, write them down, and plug them into our equations. We treat them as brute facts because there is no underlying theoretical rule that generates them. A theoretical framework called the observer-dependent theory of everything, or ODTOE, poses a different question. What if these numbers are the inevitable geometric consequences of the act of observation itself? Instead of taking them from experiments, ODTOE derives them mathematically from first principles, using zero free parameters. Any act of observation needs three components: an observer, the object observed, and an operator. Information flows forward to the object and returns, doubling these into a six-part cycle. We represent this continuous cycle mathematically with pi, tracing a full phase loop. But pi's decimals never end, so this geometric loop never perfectly closes on its starting point. The path overshoots. This creates a tiny mathematical discontinuity in the fabric of observation, known as a spiral gap. The distance between the turns of this expanding spiral is governed by another constant, the golden ratio, phi. The geometry of observation is a dynamic spiral bound by strict rules: the triad of 3, the cycle of 6, the continuous curve of pi, and the discrete step of phi. This exact spiral geometry constructs the mass ratio of the proton, 1836. The proton is a product. We multiply the full cycle of 6 by 5 distinct constraints of pi. But because a proton is defined by its own mass, it forms a strange loop, where the spiral gap is divided by the very mass it defines. This self-reference triggers an infinite series of fractional corrections, a loop within a loop, where each turn of the spiral decays rapidly into microscopic mathematical adjustments. The physical heft of matter is the mathematical result of this observation cycle folding in on itself. The fine structure constant, 137, relies on these exact same geometric rules, but it takes a different mathematical shape. Unlike the proton, light is an interaction layered over time, so its geometry is a sum. The operator's components give 4 pi cubed. We add pi squared for the return loop and a single pi for the observer's topological presence. We then subject this sequential sum to the exact same self-referential spiral gap corrections scaled by the golden ratio. Matter and energy govern different domains of physics, yet both of their constants are derived from the exact same structural geometry of observation. Let these pure, self-referential equations run to completion without plugging in a single experimental measurement. The ODTOE formula calculates the proton mass ratio at 1836.15267, matching the gold standard CODATA 2022 empirical measurements down to 9 significant digits. The fine structure constant calculates to exactly 137.035999, landing squarely inside the strictest margins of current experimental error. We are looking at 9 significant digits of accuracy, generated entirely through structural logic. No guessing, no measuring physical objects. For a century, we treated the universe as a cold machine with arbitrary settings. We looked at the chalkboard and wondered who chose the numbers. We now have the mathematical framework to show the core dials of reality are not random. These constants are the geometric footprints left behind by the very act of an observer looking at reality. Our act of looking at the universe determines the exact numbers that define it. The scales of matter and light are built into the geometry of the observer.